Well, let me talk for just a minute about where things are. If you saw the last stream, whenever that was it this weekend or something? Um, I was hammering on all this font code to get it to run, and like it was 1,000 to 2,000 lines of font stuff that I had done in C++, and I was converting it as a test of like making sure that some real software can run now, and also to well, that's basically a good enough summary, just making sure real software can run. And initially, I had had some problems in that font code that had led me to do a whole giant rewrite of a lot of dependency stuff. So that was like 2 streams ago. And then last stream was sort of once that had gotten together enough to run programs again, it was just about me seeing what I could do with it. And so in the spare time between last time and this time, I've got that font stuff working. So here's our Galaga game, and we've got font things rendering on top. They could be moving and all that. They're not, because whatever, but hey, this is the same, essentially the same font rendering code that I used in Braid in the Witness, but now in a different programming language, and cleaned up a little bit, and I'll continue to clean it up. So that's all nice. Um, it gives us, it calls out, basically the way that works is it calls out to FreeType, which is a font rendering library, and I've sort of translated enough representations of FreeType's data structures, which you sort of saw a piece of that happening last time, um, such that now font things can actually render. So that's all good. Um, and then earlier today, I decided to go through this now working font code and do what I could do to make it nicer. And one of the things I wanted to make nicer was some of the various kinds of casting that are happening. Often the language is trying to be a little more strict than C or C++ in terms of what you can cast to what else. And even during the last stream, I was doing more casts than I thought I should. One of those, at least, was due to a compiler bug that's since been fixed, but there are some more. And so there's a few categories of things that I wanted to fix, and let me just show you one of them. Oh, I also had mentioned that I'd wanted to clean up the code a little bit in terms of the C++ version of it used lots of integer counts and then pointers to data for arrays like you do in C++ sometimes, and especially in C. And I'd wanted to translate those into actual arrays. So I've done that here, right? So this, in a previous version of this code, used to be like a number of glyphs and then a pointer to glyphs. And this is now a language-supported array of unknown length, and so is that, and so is that. Now, let me show you, though, what has happened as a result of these things. What has happened is that I have a few casts that I need to do sometimes when I'm building these arrays. Now there's a whole there's a whole side issue. Okay, so let me go to a simpler one that's less verbose. Oh, they're all about equal. This one's fine. So here's sort of what I'm doing to build this array, and let me put this down here and show you what this ideally looks like, which is this, where there's this array called lookup lists, right? Let me go show that. Right, so that's this one. It's an array of U16s, and here I'm just setting the count to be equal to some number that we've parsed out of this font file, and I'm setting the data to be a new array of U16s. Now, a thing that's a little bit confusing is that right now this array new is like the C++ array new, where it actually returns a pointer to U16. Ideally, it would return an array of U16, and actually, maybe one of the next steps will be to make that work correctly. But right now, it returns a pointer to U16, and what that means is that I have to build the array manually, right? I have to set the count of the array and the data of the array. If new actually returned an array like it looks like it does, then I could have just done this. Like that would be all that we need to do, and we wouldn't have any more of the problems that I'm about to discuss, right? However, we still need to handle this version where you're initializing an array manually, because you might not be using new, right? Like you might just be grabbing some untyped memory out of your own allocator and assigning it to this pointer. So, things need to work, and then once things work, I will put them here. Now they do work, right? But the way they work right now is I have to cast this to a pointer to U8. And the reason why is a little bit complicated, but anyway, so you'll remember I just showed a second ago, this lookup lists is an array, right? But I'm using dot to reference members of it as though it were a struct. And the way that that works internally is that when you do a member dot lookup on an array, the compiler internally casts your array to this struct type, and this layout happens to match, what the compiler uses internally for the storage. And so then you can refer to these members. And that seemed like a nice, straightforward way to make this kind of functionality happen. But what that means, though, since we're just casting the array to this struct, it means the data member is always a pointer to U8 for here. It's always a pointer to void for here. And the reason for this inconsistency is just because I didn't notice, because I went back and forth about what type should things be. Should they be void pointers? Should they be pointer to U8? How automatic should be casting to and from void pointers and all that? But here's the thing. This is all fine. This should probably be pointer to void. I'm not going to change it yet because I don't know if that's going to break something else that I don't want to deal with yet. But the problem is, now anytime I assign memory to this, I have to cast it to pointer to U8, which is like the worst of all possible worlds, because you're not really getting type safety here, because you're casting to just some arbitrary pointer type that all array datas are. What you really would like is, like I said, to just say this, right? And the reason that's better is because since lookup lists is an array of U16, right, unsigned 16-bit integers, then the data should be a pointer to an array of U6, or a pointer to an indeterminate number of U16s stored contiguously in memory, right, just like C pointers. And that way you get type safety, right? Like if you're meaning to assign it to something else of the same type, you get that right. So this is a long-winded way of saying, this one should be pointer to U16. This one should be pointer to font lookup subtable, right? The data member of this array should change type based on what the type of the array is. Now, I started doing this today about an hour before the stream, or an hour and a half before the stream, and it very quickly became a quagmire. So that made me a little bit unhappy. So I'm just going to continue on with the work that I was trying to do, and I'll explain what I'm doing implementation-wise, and etc. And I'll also rethink my approach from before, because it was not necessarily a good approach. I'm going to revert anything I did to there. And I'm going to that wasn't quite the head version of the repository, because like I said, I've been working on this and trying to make it happen. And I've been causing problems. So let me go look at the problems that I'm causing. Okay, so in here, when you are looking up an identifier, right, you sort of have two basic cases. It could be a lone identifier that refers to a variable or constant somewhere in the program. Or it could be a struct dereference, like it has a dot in front of it, right? So like a binary operator dot, and the thing on the left of the dot is the struct to dereference. And the thing on the right of the dot is the identifier, and that is exactly what we are doing here. When we say lookup lists dot data, this is the part of code we're going to. We know we've got data with a dot in front of it, and we know what that dot points to. It points to this binary expression feature.lookupLists, right? Which is an array type, and we sort of want to grab the type out of that array type and put it into the data. Now, the code for this, this function that we're looking at here, resolve ident for struct dereference, handles any kind of struct dereferences, not just for arrays, but for regular old structs and for type any, right? So if you saw the demo with the any type, we sort of cast that to a struct that's called underscore any that you see here. Now for this, we actually don't know what the value pointer points to, so we want that type. That being pointer to void is fine. We're not going to mess with that. Anyway, now there's something else that happens though, because well, there's several complications, right? So this whole method of casting something to a struct, even back when I originally did it, it only works for arrays that actually have storage. Okay, so like the arrays that I was just looking at now have storage. They have a count and they have a pointer to the data, right? And a dynamic array is even more involved. But if you just say something like, an array of 256 U8s, this doesn't actually have storage. There's not like any data for the information about the array, right? All of that is just known at compile time. All that gets stored in your program is 256 U8s, right? Now, and we don't want to change that because that's one of the differences between fast, low-level C-like languages and slow, well, low-level, I don't want to say low-level because the whole low-level, high-level thing is a weird false dichotomy. Fast, it's the difference between fast languages and slow languages is how much fatty information you store when you don't need to and use, right? So here, if we're doing any kind of array, then we do all this stuff, and if it's dynamic or static, then we substitute these structs. But if it's a static array of known size, which is like that array of 256 U8s, then we do everything here in return, and we don't substitute a struct because we can't substitute a struct. There's no storage, right? And in this function, we're just doing type inference. We're not doing code generation here. So we have to do, this is sort of an exceptional case, right? And compilers get more complicated as you pile on more exceptional cases. We have one exceptional case here for type checking. So we say, oh, if you said count, then it's a signed 64-bit number. And we're, that's known by the compiler, like I said, so we're going to fill that in during code generation. And if you say data, then we grab the type out. This is all new, right? This used to just say, oh, then it's a pointer to U8. But now I've said grab the array element type and make sure it's not an SOA pointer, because if that has other connotations that we don't want to inherit. And then, we make a new type that's a pointer to this, and we set that to the identifier's type. But that's still not the code generation, right? The code generation later is going to have to substitute in the proper pointer for this. So there's exceptions already, so it starts to get hard to think about. I don't mean exceptions the language feature. I mean exceptions in terms of it's not just one straightforward thing that's happening, right? So now the problem then is I started trying to do stuff where for dynamic and static array, I said, okay, I'm going to just fall through and do all this normal struct substitution code. And then I'm going to patch it up at the end. So for now, I pasted code very similar to what you just saw down here, where we did all this stuff where we substituted this other struct. And then at the very end, we're going to set the identifier. I forget exactly even what I did here. What are we setting here? We're setting the inferred type of the identifier to the array element type only in the case where it's data, right? Because data is the only field that we need to change. Like the count and the size field for dynamic arrays are always going to be the same as what you see in that struct declaration. So this is the only one that we need to cheat about. Now, the problem I was having, well, you know, I had several approaches to this, and this was sort of the most recent one. And one problem is that all the code generation stuff that happens later, like, may be confused now about what I'm doing here, because what I'm doing here is really complicated, and I might be forgetting to like do something to somebody somewhere when I make this change, right? Also, though, this has repercussions sort of up the chain. So most recently, if I remember correctly, what my most recent problem was, I was having a crash now when I try to run this. Whoops, that's not what I wanted. I wanted that. Yeah, so, or I'm having an assertion, right? And what the assertion is that someone else is inserting a cast, which is really bizarre. So either, like, this is one of those points where I'm like, whoops, I've got old breakpoints still. Let me skip the old breakpoints, run till the assert. Now we've got this thing where, you know, we're trying to generate code for a cast, and I can look at the cast, and it's casting to a target type that hasn't been inferred, which is really weird. Like, by the time you get to code generation, you're supposed to really know what all your types are, and the way you really know is that this inferred type thing gets filled out. So that's confusing. Like, how did that happen? I didn't forget to set it here. Although I did forget to set it here. Wait, pointer. I did forget to set it there. Although it's scary that I'm getting a cast, like I'm going to have to look into that, but... All right. Let's just see what happens. Oh, it ran. I did not expect the solution to be so easy. All right. Well, so now I believe if I go to like line 1216, for example, yeah, so result.glyphs is one of these arrays, and now I'm just setting it to glyph indices, which came back from new. So I've gotten rid of these casts to pointer to U8. Like here, okay, I think we might have looked at this one. This is what the line used to be, and now it's this. You didn't see me modify it because I just re-updated to my new work wherein I had modified all these. So that's a good cleanup, actually. So why don't I let's do questions for a couple minutes about all this random blathering that I just said, and then we'll go on and do something fun. Maybe not super fun, but I'm going to make this cast operator a lot cooler than it is. We'll put it that way. Except only for about an hour, because I was going to go out and have some other fun tonight besides programming. So we'll see. So does anyone have questions about all this rambling that I just rambled? Nobody's even in the channel talking about compiler stuff. Yeah, I stream at 1080p, but this is actually almost a 4K monitor. Like if I go to the screen resolution, it goes up to 3840 by 2160. It's just, I feel like it's rude to stream at that resolution and have everybody looking at blurry text, because I don't think Twitch streams that high, so I just keep it at 1080 when I'm streaming. So everyone gets it? No answers I can fill in before we move on? Bueller. Bueller. All right. Anyway, so let me talk about what I want to do now. So as you saw in the the question came in. Are there any other stuff besides font rendering routines that I plan to port? Yeah, I probably plan to port a lot of things because there's just use, like porting that font stuff was way faster than if I had to rewrite it from scratch. Um, and it's just a nice exercise because you see what code really wants. I mean, it's still it's code written in a different language, so it wants something different than if you'd written it here directly. But it's a good way of double checking that you're not just like writing code and coding around the weak spots in your language or whatever. You're like hammering on those weak spots and let's see what happens. So yeah, I mean, I'm just as need arises, I'm going to pull over stuff. That said, a lot of the engine components of my game engines are to make up for deficiencies in C++ that this language doesn't have, right? So there's a lot of like metadata things that we don't need, right? And there's a lot of like scripting related things that we're not going to need because you can use this same language as script. So yeah, I mean, you might, for other reasons, you might want a different scripting language. Like if you want designers to have a relatively foolproof thing, then that's different. But you know, if you just want to put some text on a field on an entity in a game and have it run, you'll be able to just link this language, right? So my hope is that a lot of game engine components that I have go away. But you know, stuff like mesh loading and whatever is all going to get ported. Yes, I did work on a game that had tanks. That is true. Okay, so let's talk about another annoying thing about cast. So the thing about this language is it's trying to be more strict about integer casting or any kind of scalar number casting than C or C++ are. And that's one of the things that I ran into when this code came over was this code had not been very it had not been very careful about casting signed to unsigned or whatever. And you know, the good thing about zero glyph, that's not existing anymore. The good thing about being strict about casting is that it brings your attention to all the kinds of issues that your code might have. The bad thing about it is that in certain situations it might become really tedious because you're typing casts all over the place when you would rather not. But then the good thing about typing casts is that you can search for the word cast, right? So, you know, if I were to do this line in C, it would be like S16 desired height. And that doesn't really give me something to search for, right? Whereas if I search for the word cast, I can then audit my code later and say, how can I change these types so that I have fewer problems, right? What are the inconsistencies that I have that's causing me to cast so much, right? And there are inconsistencies in this font code as ported from C to C++. They're not major giant ones, but they're there. It's like, oh, sometimes certain coordinates are signed 16-bit and other times they're unsigned, and shouldn't they always be the same, you know, but they're not, and why aren't they? So anyway, here's the thing, though. I believe that it's very useful to be able to search for this cast, right? But as I said in the first couple of talks that I gave, even before I was designing this language very specifically, when I was just talking about what generally do we want, I got distracted by the fact that I want more light here. 1 second. Anyway, in the earlier talks, I was talking about the fact that I think low friction is very important, right? And the thing about having very strict casting is that it causes you to pay up front in order for your code to compile at all. And you may not want to pay up front. You may want to be just like sketching stuff out, and you may think, oh, well, I know there might be overflow problems here or something, or I might accidentally be casting a negative number to an unsigned, but I don't care that much right now, but I do want to go back and audit for it later. So I want to permit that kind of programming style, and I'm trying to figure out the best way to do that, right? So now one thing you could do is the C thing, where you just generate warnings and later you can compile with warnings as errors, but I don't want to implement that because I feel like we know how that goes and it's not really ideal. Although we could always fall back on that if other things don't work out. But here's my ideas first of all. So first I want to change the syntax of cast. So this is what the syntax is right now. And I had an idealism behind it, which is just like, look, I want the word cast so you can search for cast, but then I want the variable to still be the most important thing, so you see that first, and then the type is less important. Okay. Now this turns out to have not been that good of an idea. It was a bad idealism. Really what I want is something more like this, cast to S16 of desired height, because the cast and the target type are associated concepts, and you want them right next to each other. And you want to fix this expression, you want to only type one thing in one place, right? Whereas now, every time I go cast something, because the compiler is complaining that the left and the right-hand side are different types, now I have to go type things in two places with balanced parentheses, and that sucks. So I want to change the syntax to do this, first of all. So that's the first thing I'm going to do. But the second thing I'm going to do is make casting even easier, because this is a language where you have type inference, right? And the compiler is working hard to help you out. And in a case like this, if I'm just drafting code and stuff, I don't want to have to stop and think very hard about what the type is on the left. I don't even want to have to read the error message super closely and read what the type is and then put cast to that type. You can do that, and that's pretty fast, but it's still annoying. Really what I just want to say is like, look, compiler, I don't care right now. Make it work, and I'll come back later, right? And my best idea, or maybe not my best idea, but my current idea about how to do that is to just be able to say this. Where you just say cast and then no argument to cast, right? And the compiler will use this to say, oh, all right, well, this thing, it has a current type, but we're going to will ourselves to cast it to whatever needs to happen to make it match this type on the left, right? And so you can still search for cast, and maybe if we decide this is an extra bad kind of cast at some point, you could make it like capital C cast or, whatever. But I just want to make a way that you can go through your program and do this stuff and make your program work very quickly and backload this kind of type safety work instead of front loading it, right? Whenever I talk about something like Rust, I always say, well, I don't like the friction that it puts on you. And what I've been finding is there is some increased friction with being more strict about casting, and I would like not to have it. So does that make sense to people? I will check the questions really fast. Someone's saying, what about as? That's okay, but something like that doesn't matter too much, like whether the word is cast or as or something. Someone asked, am I concerned that the language I'm going to port stuff from is going to affect the design of this language? Well, it already is, right? Like, I'm porting from C++, which is the main thing I've used for 20 years, and the design of this language is very heavily influenced by C++, but not necessarily in the direct way. Like, it's mostly C++ as a cautionary tale. But yeah, I mean, you just have to be smart about what you're doing, and sometimes if code comes over from another language and it wanted a certain idiom of that language that you're intentionally not supplying in this one, then you just have to understand what that means and you want to at least look at the code and make sure that there's a plausible way to restructure it in your language that is nicer than the original one. But I don't know. It's always a judgment call. You have to look at what's happening and use that to evaluate the design of the language, and but not overly so, right? You don't want to jump to wrong conclusions, and it's very easy to do that. It's just like playtesting a game, actually, right? You want to put your game in front of players as a reality check and see what happens when they play it, but you don't want to listen to them too much because otherwise they're telling you what game to make, and that's no good. It's going to be a terrible game, usually. If I thought about having grouped warning messages by type, yeah, probably. I want to have warnings. Most compilers do warnings where they associate an integer ID to a warning. I want to have like a string ID, and maybe there's string prefixes that are common among groups of warnings. It's to be worked out. Can you using cast to make everything just cast implicitly? Not right now, although that would be kind of funny. Do I still get semicolon emails? I got one that was actually worse than a semicolon email. I forget what it was now. But yeah, there's no end to that kind of thing. How about making cast a compile time hash thingy like a directive, someone is asking? Maybe, yeah, but that's not going to change the fundamentals of what we're doing, I don't think. Someone says, it seems dangerous. Maybe your code changes way up the stream, and then the cast does something way unexpected. Yes, that's true. But that's true with anything where you have type inference, and it's your job as a programmer to make sure you're not being dangerous. You don't want the language to encourage things that are super dangerous, but this isn't going to... I don't think this is going to be super dangerous. And in fact, this kind of autocast, we could say that it only works on scalar types, like it doesn't work on pointer types, for example. That would be a reasonable restriction to put on it, so that because crashes that you might have are going to be crashes involved in like casting stuff from totally wacky struct type to another struct type or something. So if we don't do that, it's at least kind of relatively safe, Anyway, so I don't know how far we're going to get on this tonight, because like I said, I want to go out and do stuff. But first, I'm going to change this syntax to this with the parentheses, and then I'm going to do this. Now, the other thing I didn't mention that's a little bit negative about this syntax is there's an ambiguity here, if you haven't noticed it already, which is, in this language, it's a language where you use parentheses to group expressions. So instead of this second line here, I could say this, and it's the same thing, right? Like this is just parentheses around an expression, and then there's an expression in there. So what that means is if I want to do cast without a target type, and then I lead with a parenthesis here, the compiler can get confused and think this is the type, and then barf. So I'm not sure what the best approach is about this right now. I'm thinking that this is probably a very, very rare case, and that if you want to say this, maybe you do that, and it means the same thing as cast without a type inside. But if you had that, that would still work, but you wouldn't need this. You could do that. But that's a little bit, it's a little bit of a syntactic singularity that is not particularly nice. The other thing I could do is look for the end of the I could parse this as an expression, whatever's in here, and then see if there's another expression here, right? And if there isn't, then I decide that this is this, but I'm not sure if that's going to have any chain reaction with other syntax. I haven't totally done that back-end compiling to C catching up, although I want to do it soon now because I feel like everything's in a good place to do that. What about cat? Oh, somebody said, what about cast open for an A plus B, which is what I was just talking about. So good for you on catching that. Maybe put cast at the end of the line. I don't know, because you usually... the thing about putting it in front is it's closer to the thing that you're casting to, because you're usually there's something on the left and you want to cast the thing on the right to match the thing on the left. So if I did it this way, which someone in comments is suggesting, that does solve this syntactic ambiguity. I'm not sure if I like it. We don't do a lot of postfix operators here, and it's sort of like a postfix operator. Although we might do postfix operators. Yeah, I said that we can have a separate keyword for autocast. That's fine. That's an implementation detail. What I want to do is get the basic stuff working. People are suggesting ever more weird syntax. What if I change the parentheses to something else like a colon? You can do that. You can use a colon, you can use an exclamation point, you can use all kinds of weird things. It's just that those things have meaning in the language, and you want to be careful about appropriating things that have meaning. You know, I could do this, and that's probably not ambiguous, but like curly braces are kind of hard to type, I think. Although I guess they're not really harder to type than these. They just feel harder to me to type because of where they are on the keyboard, maybe in my typing style. I don't know. There's no way I'm going to do the C++ angle thing. That's just so ugly. Anyway, let me spend 1 or 2 more minutes thinking about this before I start typing. So I'm just going to put out the different variants of this. So this is old. This will no longer be good. Of course, all my programs are going to break. Let me. What's a relatively short demo? Inlining initializer test. I don't know if those have casting in them. Whoa! I broke things. I tested all these like an hour ago and they all ran, so that's too bad. Well, I'll have to fix that demo. Okay, that one runs at least. What was wrong with doing cast type comma expression? I don't want to have to put the parentheses at the end of expression because it means you have to edit 2 places to insert a cast, right? It's the same in C++. It's a pain in the... In C++, you have to go like... If you're not using C-style casting, you have to go... If you go to go from expression, right? In C++, you have to go static cast dest type open paren, and then you have to put a close paren way over there, and it's just too much, right? So if you can keep it all in one place, I don't care that much if it's all at the beginning or all at the end, but you just keep it all in one place, so you don't need to go here and here. It's just a little bit better. Yes, being context-free is a goal for the grammar. This language has to be context-free because it doesn't have header file. There's no defined order of compilation for this language, so you can't have context. Unless you're talking about very limited things like opening a block string in the lexer or something, you know. Just treat the type as a function. That's ambiguous with a function. just not the same. All right, so let me just, anyway, the finer aspects of it are perhaps, I'm going to be ambitious, and I'm going to go through, since we know the font stuff works, I'm just going to go through here and start changing all the casts, even though there are a lot of, oh, I should have made a regex that does this. How many casts are there? There's not that, oh, there's a lot, really. I was going to learn, because I never use regex Emacs, and I was going to go through and do it, but you know what? It's fine. We'll do it by hand. Yeah, there's a lot of casts. Especially down here, this add letter quad stuff is like, when I was doing it, I was like, oh yeah, none of these should really be floats until as late as possible. You don't want to do most of this font stuff in floats. Like when I originally wrote it, I thought like, oh, you might want to bump things over by subpixels or something, but you actually don't, because the font rasterization is made to like land on exact pixels, you know. So it's just, it doesn't, you never want to do anything by a subpixel amount, as it turns out. All right. Anyway, let's go into the. Let me go. Do I have a cast in here? There's a cast in here. So any simple program is actually a good test of the thing, because everybody includes this basic module. So in order for that to work, oh, this is old. So in order for anybody to parse, once we change the syntax, it'll have to work. So let's do that. So let's go in the parser. So I actually, it's kind of an old, I don't really use it right now, but I have two cast keywords. There's big cast and little cast, and big cast is that, and little cast is that. And the idea was going to be that big cast is for more serious casts, but I don't have clear in my head what that is, or even if I'm really going to do that anymore. So we just treat them both the same right now. When we see the keyword cast, we make a node for the syntax tree. We look for a parenthesis. If we find it, we parse the expression inside the parenthesis, and then a comma, and then the type instantiation, right? So we want to change the order of all this stuff. So the simple version of this is just going to be like this. Instead of expression, comma, type instantiation, we're going to go this, we're going to go there, open paren, type instantiation, find the close paren. If we did, then we parse an expression, right? Now, if we didn't, then the compiler registered an error, or it reported an error, like, oh, we didn't find this close paren. And as soon as the compiler reports an error, it sets a flag that means that we will not ever generate code. So, like, in theory, that's actually all I have to do. In theory, that works. Now again, this isn't including the optional autocast, right, which is a more complicated concept. This is just changing the basic syntax. So let me try that. There we go. So that's exactly what we expect. So in basic line 92, it's complaining that things are unexpected, right? So really, that already looks better. Let's try that. Hey, look, it runs. So that was a relatively easy change. And for my next trick, I'm actually, because I want to keep the font stuff running, I'm going to go and very manually, painfully change all the casts. Or should I try to learn Emacs regex really fast? I don't know. whoops. 361 cast pointer to float a.data cast. Whoops. Get rid of that paren. Oh, TD. Yeah, I should figure out the regex. Does anyone know Emacs well enough to just tell me how to do this? Right, I want to change cast some amount of white space or whatever, open paren a comma b to cast open paren b close paren a. It's very simple, and it's just not an operation that I ever do. Certainly are. So these casts were, interesting tests of the type system. They're not, for the most part, the same kind of casts that we're talking about in the font demo. Oh no, actually, this is part of the vtable implementation, actually, which is different. Oh boy. This is, by the way, the second longest demo program, so like it's 900 lines. So it's not surprising that I have a lot to do here. And it was all about casting types to other types because of the vtable stuff. Oh, this is interesting. So the void pointer rules got looser. I figured that since most of the language is a lot stricter, whenever you have void pointers, it's okay to autocast because that's what you want for void pointers, and it's very intentional. So I think I can just get rid of that cast. Yeah, because you'll autocast to and from pointer to void. Oh, now we have the same problem. All right, well, that's fine. I can debug that later. Someone is saying it's hard because it's not regular due to needing parens to match inside the first part. That's true. I didn't think of that. It's not really a regular expression. You could do a regular expression that handles most of the cases, because most of these cases don't really have parens in there. All right, well, converted demo using sway.jai to new cast syntax, but there is a problem with it running, and that problem is not due to the cast thing we just did. It was due to the array referencing thing that we just did, and I need to go fix that, but I'm not going to do it now because I don't want to be ADD in terms of what thing that we attack when. I want to keep doing cast stuff. Let me just see if there are other demos that don't compile. Yeah, so these are all the previous programs that I gave these presentations on, and I feel like it's good to keep them running. Just search for cast. There. There's only one. All right. What other demos? Type info 14. Oh, there's going to be some casts in this one because you remember the type info stuff is all about casting from one struct type to another type in order to extract stuff out, if you remember that. So there'll be a fair bit of this. But again, these are not like the bad kind of these are like intentional casts. They're like before I got to this if statement, I didn't know what this thing was, and now I do. And so, you know, so now I'm exercising my additional knowledge. Now, you could think of ways to do that that don't involve casts, like some languages have, I don't know, ways of querying a type, and we might do that later. But for now, I do it with casts because that is the C way, and it is known to work and known to be fine. There's some things about it that are ugly, the C way, like especially with older C code, this kind of casting can cause some bad bugs and things. But it's my belief that that mostly has to do with other features of older C that were too squishy. And now that C is, if you use ANSI C in the way it's intended to be used, it's not really that squishy anymore, and this kind of thing isn't a problem. But we'll see. As always, any decisions made in this language are provisional and will be changed. Let's at least, so we're up to 284. Oh, I did something wrong here. Oh, 315. Did the same thing. 360. We got more casts. So again, in most of these places, like the string to U8 casts are dumb because I don't do good strings in the language yet. That'll be handled at some point. But that's definitely a place where I would use a cast without saying what the type is. Pointer U8. So all these casts a string are would go away when I have better string handling, basically. That's the plan anyway. And that plan tends to be followed through, right? Like I have things that were ugly for a long time because we didn't have polymorphism, and now we do, and those things are neater. A lot of casts in this demo. Oh, this is a paste of that earlier code, right? One of the things I do in these demos sometimes is I'll paste the same code slightly modified, just because it's an example and we want to iterate on the same kind of example and revisit it. And so the unfortunate thing is that means I have to do this kind of change several times. Wow, how long is this? Oh God, we're over halfway through. A regex would handle this most of the time, because there's almost never. In fact, I don't know if there's been parentheses inside for any of these. Tedious pointer U8. I'm going to have even more fun with this when I change this to a different syntax, the pointer thing. Oh, now here's interesting. Maybe I don't really want to do all this. So the thing I didn't think about is what's the precedence of cast? I think I want it to be very high precedence. I think I want it to bind very closely to things. I don't know. What do you guys think? In a case like this where it's cast something. In this case, it doesn't really matter because this is pointer math. Or no, it does matter actually. This would be a very different meaning. You'd add a different amount. So this might be a case even where I might want to hand specify this, but I wonder what the default is. Yeah, someone else said high precedence too. This one I do want to be very specific because no matter what the precedence is, I think it's you want to specify the intent. The intent of this code is like, I want this to be pointer to U8 so that the offset in bytes is really in bytes, right? It's not about making the type work with this thing on the left. The thing on the left is in fact auto to match whatever's on the right. So really this cast is all about the offset computation. And so I'm just going to leave the parens there and be very clear about it. I believe right now the precedence of cast would actually be very low. The way I do precedence is a little different. You saw that, like, if we go back to the parser code, right, you saw that I basically just say parse expression, and parse expression just keeps going as long as there's more expression to parse. So without these parentheses, it would just parse this whole thing. And I'll show in a little bit probably what I do about that. Somebody remind me if I don't do it to go fix the precedence. Replace cast of all that stuff with cast 2.1. Maybe I'll try that. Let's see. Oh geez, it's more of the same pasted code. Nope, same thing. Although, yeah, I mean, the parens don't really change anything anyway. Like, we're still going to parse this whole expression. Like, basically, until I fix the precedence, this is gonna do the wrong thing. Program's gonna break, which is making me a little bit question this decision, but I think I just want to use cast with the syntax for a while and then just sort of know through experience whether it's a problem. Yeah, something like this too, like this really had better be, although equals isn't an expression anymore, but I may parse it as an expression. So this really needs to be high precedence. Okay, that's all the casts in the file. Let's make sure we got them all. It's probably not going to run correctly. Yeah. So it's complaining this can only be used at statement level. And the reason is, oh, it's this one that we just did. The reason is it's parsing it as this. Right? So that's no good. And equals is not an expression in this language for reasons that I talked about in the arguments demo. Oh, yeah. Someone's suggesting, right. Let me find those. That's what happens when I'm a little tired or I'm thinking about too much. Someone's saying, well, your parens should be that, and yes, they should. They absolutely should. And I guess I could do that to fix this equal problem that we have also, right? Okay. Ooh. We're crashing somewhere in that program. So I might have missed one of these. I want to figure that out before I go. I'm looking for, well, let's just see where it crashes. course, where it crashes may not tell us much about who set up the data wrong or whatever. All right, tests. So right now I'm not running the compiled version. I'm running the interpreted version of the program. So it crashes the compiler because it's not sandboxed yet. So which demo is this? Demo type info. Ugh. You hit the wrong key and just bad. I have no idea what's going on. Debugging. Test demo type info. All right, let's see where it's crashing. It's running an instruction. What? Debug expression file name. It is in the correct. It's in the correct file. Line number 449. Oh, right. So we're casting to. We need this. What do we need? We're casting for every arg. We need to cast the value pointer. Wait, that should have been that way already, right? Yeah, that didn't change anything. Cast a pointer to string it.value pointer. That didn't change anything. So this is an array of any, right? This is var args. Let me break this down until I get a version that works, and then we'll figure out exactly what's happening. So I'm going to say P is it.value pointer. S is cast to a pointer to string P, right? So there's really no syntactic ambiguity here. And then star S. So hopefully that works. If that doesn't work, then whoops. What am I doing? 4 args, this. All right. Still crashes. So maybe what we're passing to second routine first routine 1, 2, 3. Maybe we had some weird. Oh, no, this part works. See, this works, and that's not really any different than this thing up here. So this isn't really the problem, actually. I'm going to leave this the way it is, but this wasn't the problem because this works fine, and it's the same thing. So and didn't we run this before I did the casting change? Maybe I didn't. Maybe I didn't. Yeah, the args are of type any. There's a whole long demo where I demoed all these features. I forget what was it called, that demo? Oh, it was the type info demo. That's what file I'm in. It was called runtime and compile time type information. You can see it on YouTube. Go into all this stuff. Okay. I wonder. I'm going to say for args printf debug first value pointer is some hex number and it dot value pointer. I just want to make sure that like this function call is still working and stuff. Second, see what happens there. All right, first, oh, see, it's not working. So this has actually nothing to do. You know what this has to do with? Oh God, okay. This has to do with the other thing that I thought I had fixed successfully very fast. Remember how I said, hey, I do all this struct casting, and then type any goes through here also, right? Well, this has to do with type any. And if you look at this, 6D, 61, 6E, 5F, that is not a pointer value. That is for ASCII characters somehow. We're like dereferencing something too far, and that's the contents of a string, right? So like ASCII hex table, right? 6D is M, 6.1 is A, 6E is N, or MA, and right, 5F is underscore, right? What string is that? Wait, what is it? 6061. Maybe it's not a string in the program. Anyway, it's very obviously an ASCII string, so we're like dereferencing memory in a bad way, and this is very likely due to the previous change and has nothing to do with this cast change. So what I'm going to do is I'm going to check in the cast change for now. I also want to grab the Emacs thing that this dude sent earlier from the scroll back. If I can find it, if it's not gone. There it is. I'm just going to save that so I can try it out later when I have to go do the whole file. Because I've only got about 10 minutes or less here. And so I think what I'm going to do, I'm going to check in this cast change, and then I'm going to go back, and I said I didn't want to be ADD about what I'm attacking, but this is serious enough. You know, really, if you're being serious about this stuff, you run a regression test that runs every test in your test folder after every change. And had I been being disciplined, I would have done that before I switched to the cast syntax thing, but I wasn't. So now we've got some programs with the wrong old syntax and other programs that don't really run. So the first thing that we noticed that didn't really run was this one. So let's do that first, because that may be an easier problem and that may give us clues about the other thing. And we probably won't finish this right now, because like I said, we only have a few minutes. But let's look at what is going wrong. Make packing variant. Oh, right. Wait. So this is in my new code that I just pasted. I'm making a packing variant of something that is not a struct. So what is it? It's in line 508. Well, it is an entity, so I don't know why it thinks it's not a struct. Oh, because it's an array of struct, right? Is that what's going on? No, because this should be the array element type. Let's look. Data type is a struct, right? The inferred type should also have that struct pointer. All right. This is exactly as expected. So let's see what happens. So we're calling down to make packing variant. This is totally dumb. This was just a paste error. And that could have any kind of, if you pass the wrong type, and essentially I'm casting stuff to the wrong type in this code. Anytime you have a static array of known size, and we didn't have any of those, or we did, actually we did, but we never said .data on them in our font code. But here we are, I think, right? We're saying like a.data somewhere. Yes, right there. So this code path was not exercised by the font stuff. All right, well, let's fix that. Pointer to vtable. Why is vtable? Oh, because T is not capitalized. Hopefully somebody caught that on the stream comments and, hey, it runs. So that's good. Now that could be the same problem that was causing this weird thing with the any, but I kind of doubt it. I kind of feel like the any thing is different. So let's go back to that demo. Although I feel more successful than I expected to be. All right, so this is still crashing in the same way. So that, I fear, is not going to get solved today. So why don't I leave it there? And I'm going to go back and I'll wrestle with this in my spare time tomorrow morning, and hopefully it'll get solved relatively quickly. And then we can, maybe during a stream tomorrow or Friday, we can do the auto-cast part of the cast syntax. That'll be interesting. But any final questions before I sign off about what we were talking about today? I'm glad you guys appreciate this. It's fun to do it. It's all, whenever you stream programming, like on the one hand, it's slower because you're explaining everything out and trying to provide context, whereas if you're just programming, you just do it, right? But on the other hand, it's always fun and interesting to like think things out verbally that I normally wouldn't even think about. I would just reflex them. It's interesting to do that. So that's fun. Which ships first, this programming language or the witness? The witness will ship first. Unless you mean like a prototype-ish version of the language, in which case this might ship that first. But like a production quality useful version of this language that I claim that you could actually write real software in won't be till after the witness ships. Compiler bootstrapping question emails are the new semicolon emails. It's terrible. Where can you find out more about what I'm doing? I have a YouTube channel. You can just search on YouTube. This video is going to go up on that channel, and there's a bunch of, there are videos like this where I'm just randomly working on whatever task. And there are also videos that are more formal presentations of features in the language and stuff. Which reminds, let me go to my to-do list. Okay, so we're in the middle of cast syntax change, and we want to make cast have very high precedence, and we want to what was it? Oh, fix the crash in what demo is this? Demo type info. Would I ever open source Braid? Maybe at some point. All right, folks. Good night. See you later.